All right, assignment 2.6. We're going to use these graphs and say where it's increasing, decreasing, and where the maximums and minimums are. So it's increasing if it's rising. So from negative infinity up to negative 2, it's rising. So we go the x values. So from negative infinity to negative 2, it's rising. It also is rising from 2 to infinity. And it's decreasing from negative 2 to positive 2. It's falling. And then in terms of the maximums and the minimums, there's a relative maximum, and it's the point at negative 2, 4. And there's a relative minimum as a point at 2, negative 4. That's what we're doing. Number 2, look off the graph. Where is it increasing? So this increases up to negative 2. And then it increases from 0 to infinity. It's decreasing where it's falling. So from negative 2 to negative 1. And from negative 1 to 0. So it's decreasing and decreasing. You could actually write it from negative 2 to positive 2, but I like writing it with the asymptote, breaking up the interval. The relative max, the high point turning is at negative 2, negative 4, and there's a minimum at 0, 0. So this is a high turning point, that's a maximum. This is a low turning point, that's a minimum. In number 3, it increases from negative 2 to 0, and it increases from 2 to infinity. It decreases the other intervals, so it decreases from negative infinity up to negative 2, and decreases from 0 to 2. The maximum is at 0, 4, and there's 2 minimums, and that's at negative 2, 0 and positive 2, 0. Number 4, it's increasing from 0 to infinity, and it decreases from negative infinity up to 0. We have no relative max, but we do have a minimum, and that's at 0, 0. So we only have a low turning point, we have no upper turning point. In number 5, it says, use the first derivative number lines to answer these questions. And so for number 5, when the first derivative is positive, it's increasing, and when it's negative, it's decreasing. So for 5a, it's increasing where the plus sign is. That's negative infinity to negative 2, and 0 to infinity. It is decreasing from negative 2 to 0. And then it says, where's the relative max? So when I look off this number line for number 5, when it changes from increasing to decreasing, it creates a maximum. So rising to falling creates a maximum. So at x equals negative 2, I don't know the y value, but I know the x value of it. For a minimum, it's the other direction. So when it falls and then rises, so if it's falling and then rises, at 0, there's a minimum. That was B, C, and D. Number 6. So if you have, I'm just going to draw the number line. So the first derivative number line. Now, it says that x can't equal 0. So at 0 is an asymptote. So it can't be a turning point. But the signs are negative, positive, negative, positive. So it increases from negative 2 to 0 and 3 to infinity. It decreases from negative infinity up to negative 2 and 0 to 3. So increasing, we're looking for the plus signs. Decreasing, we're looking for the negative signs. Next, if it decreases and then increases, it creates a minimum. So at x equals negative 2 is a minimum. Again, if it decreases and then increases, it creates a minimum. 0 is an asymptote. There is no turning point there, and we have no relative maxes. Number 7. Which of the following problems from 1 to 4 match this? So increasing, decreasing, decreasing, increasing. And at negative 1 is not a critical number. So at negative 1 would be an asymptote. So if you look, negative 1 and it goes increasing, decreasing, decreasing, increasing. Which one matches that? So number 7 matched with, what number did I just look at? Number 2. For number 8, these are all critical numbers, and it goes decreasing first, then increasing. So decreasing, increasing, decreasing, increasing. So these are the critical numbers, and 0. So you can see that 8 matched with, which one is look? Number 3. Nine says, you're given a function and you have to find increasing, decreasing, and maximums and minimums. So I'm going to take the derivative and then I'm going to make it equal to 0. When I solve this, x equals 4, that's a critical number. So I'm going to draw a number line for the first derivative and label 4 on it. And then into the derivative, if you plug in a number smaller than 4, like 3 or 2 or 1, the answer is going to be negative. If you plug in a number bigger than 4, the answer is going to be positive. So where is it increasing? From 4 to infinity. Where is it decreasing? From negative infinity up to 4. This creates a minimum. It falls and then rises. That's called a minimum. So there's a relative minimum at 4. And if I want the point, you see the point, it does say the point. If I want the point, I got to plug 4 into the function. That's 16 take away 32. So there's a minimum at 4, negative 16. And there's no maximum. There's only a minimum. This would also be the vertex of this parabola. Same thing. Number 10. Another parabola, so there's only going to be one turning point. It's concave down, so it's going to be a maximum. But let's go through the work. So you take the derivative, make it equal to 0, solve for x. So if x is 1, this is 0. Draw a number line, label 1, go back to the derivative, plug in a number smaller than 1, and it's positive. Plug in a number bigger than 1, and it's negative. It rises, then falls, creates a maximum. So again, it increases from negative infinity up to 1, and it decreases from 1 to infinity, and we only have a relative maximum. Now, to find the y-coordinate of that, we go back here and plug in 1. That's 10 take away 2. So we have a maximum at 1/8 and no minimum. Number 11. This is not a quadratic, so it could have two turning points, or may not. So first take the derivative, make it equal to 0. We're going to factor a 6x out of this. So we actually have two critical numbers to look at, 0 and -1. Draw a number line, label -1 and 0 for the first derivative. Plug in a number less than -1. It's easier with the factored form, so it's a negative times a negative. That's positive. Plug in a number between 0 and -1, like -0.5. That's a negative. This is a positive. So together that's a negative. Plug in any positive number, and the answer is positive. And so we have a maximum and we have a minimum. So first of all, it increases from -infinity to -1 and 0 to infinity. It decreases from -1 to 0. And then we have max at -1. Now, if I plug -1 into here, what do you get? -2 plus 3. That's 1. And then a negative is 12. So it's 13. So there's a maximum at -1 and 13. Oh, you know what? Darn it, darn it, darn it. So I didn't take the derivative correct because -12x would have been -12. I'm going to do it again and do it right. I'm sorry. I have the answer key up too. I should look at it more often to make sure I'm not making a mistake. So I'm going to take the derivative here properly now. 6x squared plus 6x minus 12. And make it equal to 0. I'm going to divide everything by 6. And then I'm going to factor it. So that's plus 2 and minus 1. So if I solve it, the two critical numbers are -2 and positive 1. I'm going to draw a number line for the first derivative, label -2 and 1. Into this derivative, the factored form, if I plug in a negative number, a negative times a negative is positive. Now I'm going to do the multiplicity. It has an odd multiplicity. So the signs change with odd multiplicities. And so those are the signs. It's increasing from -infinity to -2. It's also increasing from 1 to infinity. It's decreasing from -2 to 1. This is a maximum and this is a minimum. So at -2, plug -2 in. I'll do it for you. The answer is 20. The relative minimum is at positive 1. That's 5 take away 12, so that's -7. All right, now number 11 is done correctly. Sorry. Number 12. So I'm going to take the derivative. It's not bad. When I multiply this, the 3's will cross out, the 5's will cross out, and you're just left with x. 5 take away 3 is 2/3. Same thing here. When I multiply the fractions, they all cross out and leave me with -1. Subtract and you get -1/3, and the derivative of 1 is 0. I'm going to write this algebra friendly to a point. I want you to recognize that x can't be, that one of the critical numbers is 0 because it makes the derivative undefined. And the other answer here, if I plug in positive 1, it gives me the answer 0. So by doing some observational skills, plug in 1 for x, and 1 to any exponent is 1, and that gives me the answer 0. So these are my two critical numbers I'm going to use. That's 0 and 1. this is what I'm going to use right here to see if it's positive or negative. If I plug in a negative number, if you cube root it and square it, it's a positive number. Here, if you plug in a negative number, the cube root of a negative number is negative. So a negative times a negative is positive. So that's positive. If I plug in a fraction like a half, here, when I do that, when I do the reciprocal, this is going to be larger than this. So therefore the answer is negative. And then if you plug in a number bigger than 1, this will end up bigger than this fraction. So the answer is positive. So those are the signs. So where is it increasing? Is from negative infinity to 0 and 1 to infinity. It's decreasing from 0 to 1. This creates a maximum, and that creates a minimum. So we have a relative max at 0. And if I plug 0 back in here, the answer is 1. There's a relative minimum at 1. And if I plug 1 in here, I get 3/5, take away 3 over 2, plus 1. Common denominators, all that good stuff. And the answer is 1/10. All right, number 13. This is good calculus. Step 1 is to take the derivative. Make sure I did it right. I think I did. Step 2 is to make it equal to 0. So the only answer for x is 0. Draw a number line. Here's the derivative. No matter what, if I put a negative number in or a positive number in, the answer is always positive. So this is forever increasing. It's called monotonic. It never decreases. And there are no relative max or mins. There's no turn in the graph. Number 14. You're going to take the derivative here. I got to use the quotient rule. So, I don't know if it's going to clear up. The bottom, I just ran out of juice there. I'm going to try a different pen. So the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Recognize the domain restrictions are at positive and negative 3. We need them for our number line, but they are not turning points. They're asymptotes, so we need to remind ourselves of that. If I look at the numerator, so if I make this equal to 0, just the numerator, I have x squared take away 9 minus 2x squared. So that's what I'm going to solve. That's negative x squared minus 9. I think it's imaginary, right? Yeah. So if you try to solve this, if you add x squared, this is imaginary, the square root of a negative number. So the only critical numbers are these. There are no turning points. So all my only critical numbers are 3 and negative 3. And the denominator is always going to be positive. And the numerator, notice how we have a negative and a negative, no matter what, will always be. So if I look at negative x squared minus 9 over x squared minus 9 squared, no matter what number I put in for x, it will always be a negative over a positive. So that means it never decreases. It never increases. It's always decreasing. You can write it that way. And there's no relative max or mins. Number 15. There are no domain restrictions. the derivative is 2/3 x plus 1 to the negative third. To write it algebra friendly, it'd be 2 over 3 and the cube root of x plus 1. So there are no critical numbers to look at for number 15. If I look, the only critical number is -1, and that makes the derivative undefined. Nothing makes it 0. If I plug in a number smaller than -1, like -2, the answer is negative. If I plug in a number bigger than -1, then the answer is positive. So this creates a minimum here, and it is a minimum. It's not an asymptote there, so that critical number matters. So where is it increasing? From -1 to infinity. Where is it decreasing? From negative infinity up to -1. We only have a minimum. And the derivative is undefined, but the function itself is continuous. So it is create a minimum. So it's at -1 plus 1, that's 0. And there are no relative maximums. All right, number 16. So x can't equal -1. That's a critical number. Well, it's not. It needs to be on my number line. And then the derivative is the bottom times the derivative of the top, which is 1. The top times the derivative of the bottom, which is 1. And then the bottom squared. So x take away x, and 1 subtract -1. So this is what you're left with. So -1 is my only number on the number line. There's nothing in the numerator. And -1 is the restriction, which is an asymptote. If I plug in a negative number, you square it. This is always going to be positive. So it increases from negative infinity up to -1, -1 to infinity, or just all the way across. Decreases never. And there is no relative max or mins. That's number 16. Number 17. The good old polynomial. Take the derivative. There are no restrictions here, so go right to taking the derivative. Make it equal to 0. I'm going to factor out a 2x squared. So one answer is 0, and the other answer is 3 over 2. Draw a number line. Label 0 and 3 over 2. Pick a negative number, and you get a positive times a negative. Pick 1, and you have a positive times and notice the multiplicity. The sign's going to change the same. The multiplicity here, it's going to change. So it's negative, negative, and then positive. So only here do we have a turning point, and it's a minimum. So it increases from 3 over 2 to infinity, and it decreases from negative infinity up to 3 over 2. There's a relative minimum at 3 over 2. And if I plug it into here and simplify it, it's negative 27 over 16. There are no maxes. All right, number 18. See if we can do the trigonometry. The derivative is just 1/2. The derivative of cosine is negative sine. Make it equal to 0. So I'm going to add sine to the other side. So if the y value is 1/2, the x is positive or negative root 3. This is a 30-degree reference angle. It's over 6. So this is quadrant 1 and 2. So it's pi over 6 and 5 pi over 6. Those angles solve that equation. Do a number line from 0 to 2 pi. If I plug in an angle here, like pi over 3, it's 1/2, pi over 6. So if I plug in a number between 0 and pi over 6, the answer is going to be smaller than 1/2. So that means it gives you a positive answer. Between pi over 6 and 5 pi over 6 is pi over 2. That's positive 1. That's going to give you 1/2 take away 1. That's a negative answer. At 5 pi over 6, something bigger, so like pi. If I plug in pi here, the answer is 0, which gives me a positive answer. So there it alternates back and forth. This is increasing from 0 to pi over 6, and from 5 pi over 6 to 2 pi. This is decreasing from pi over 6 to 5 pi over 6. We have a maximum at pi over 6. At pi over 6, we get pi over 6 divided by 2. That's pi over 12. At pi over 6, cosine is root 3 over 2. So it's pi over 12 plus root 3 over 2. That's the maximum. The minimum is here. It falls and then rises. So at 5 pi over 6, 5 pi over 6 divided by 2 is 5 pi over 12. Cosine at 5 pi over 6 is negative root 3 over 2. So there's your maximum and there's your minimum. Number 19. I know trigonometry is challenging. Knowing your unit circle. We keep practicing. Try not to give up. So we're going to take the derivative. That is cosine minus sine equal to 0. I'm going to add sine x. So the angles where both the x and y coordinate are equal to each other are pi over 4 and 5 pi over 4. This is positive, positive, and negative, negative. Draw a number line. Look at the derivative, which is here. Cosine is bigger than sine between 0 and pi over 4. Here it's going to be negative. And then again, when it's bigger than 5 pi over 4, like 11 pi over 6, yeah, it's going to give you a positive answer because the negative times the negative is going to be positive. This is a maximum. This is a minimum. So we have a maximum at pi over 4, then sine at pi over 4, plus cosine at pi over 4 is root 2 over 2 and root 2 over 2. So that's 2 root 2 over 2, and if you simplify it's just root 2. The minimum is at 5 pi over 4. Same thing is going to happen. It's just that both of these are negative at 5 pi over 4. So it simplifies to negative root 2. And there's your maximum and there's your minimum. Number 20. It says, don't use a calculator. Are strictly monotonic on the interval from 0 to infinity. So if I take the derivative and equal to 0, only 0 is a critical number. So from 0 to infinity only, if you plug in a positive number here, and so the answer is yes, monotonic, the sign doesn't change. 21, if you take the derivative, so the only answer here is where it's undefined at 0. So again, 0 to infinity. If I plug in a positive number, it's going to be positive. Yes, it's monotonic. 22. It doesn't change signs from 0 to infinity. Assuming this one's going to change, we'll see. So the derivative, 3 times the third is 1. Subtract 1 to the exponent, minus 1. So when I solve this, I get the answer positive and negative 1. But I'm only looking from 0 to infinity, so I'm just going to use positive 1. If I plug in a half, I get a negative answer. If I plug in a number bigger than 1, I get a positive answer. So this answer is no. It is not monotonic because the signs change. 23. These are review questions. I love review questions. So you're given the position. If you don't get review questions, you'll just forget, and you're just learning new material and forgetting everything else. And you can't move forward that way. So in 23 it says, on which interval is the ball moving upward? So take the velocity, which is the derivative, make it equal to 0. So t is equal to positive 2. That's where the velocity is 0. And then if I plug in a number smaller than 2, it's going up. Well, it goes from 0 to 4. So here it is. And then it goes down. So it says, on when is it moving up? And so the answer for A is 0 to 2. B says, what's the maximum height? Well, that's 23. 24, what's the maximum height? So at 2 is the maximum height. So I need to plug 2 into the position and get an answer. I'm going to look at my answer key. So if you plug in 2, it'll give you your answer. And that's 70 feet. 20, that's 24. 25. For what time is an object has increasing velocity when its acceleration is greater than 0? It has increasing speed when the velocity and acceleration have the same sign. So for what time is the velocity increasing? So I need to take the acceleration to find that out. And so the answer is never. So when the acceleration is negative, that means there are no critical numbers. So the acceleration is always negative, so the velocity is always decreasing. When is the speed of the ball increasing? So for this one, the velocity, here, let me take, this is the acceleration. Underneath, I'm going to write down the velocity of what I did. And when do the signs match? So from 2 to 4, the signs match. And that means speed is increasing. That means it's getting faster as it's going down. So signs match, it's going faster. So it's increasing, the speed is increasing, going in a downwards direction. 26. I got to turn the page. So we have a function, and it has a relative minimum at 2, -4, and then find a and b. So take the derivative equal to 0. in a equals negative 2x, but we know that at 2, the derivative is 0 because it's a minimum. So if I plug 2 in, a is equal to negative 4. Then if I come back here, you have a point, so the y value is negative 4, the x is 2, and we just found out a is negative 4, and then I can solve for b. So I get b being 0. Is that right? It is. So when a is negative 4 and b is 0, that gives you a minimum at 2 and negative 4. 27. Without using a calculator, find the absolute extreme. So we have a function. We have an interval. To find the absolute extrema means we're finding the greatest y value and the least y value. We're going to take the derivative. We're going to make it equal to 0. So when I solve this, we got positive and negative 1. Both are in my interval. So I'm going to do a table of values. So we have positive 1 and negative 1, but I also need positive 3. If I plug in positive 1, I get the answer negative 7. If I plug in negative 1, these all become here. So that's negative 4 plus 12 plus 1. Was it 9? And then if I plug in 3, I get 73. And so the absolute max is 73, and the absolute minimum is negative 7. 28. Without using a calculator, find the absolute extreme of this. Whenever it's absolute value with calculus, we should graph it. So if I graph this, it'd be hk. So the h is 2 and the k is 2. So at 2, 2 is the vertex, and then it goes up from there. And it's graphing from a 1 to 4. So you have 1 to 4, and think, where's the minimum? So the absolute minimum is the y value there, which is 2. The absolute max, well, it's going to be one of the n values. This is going to give more of a maximum. So if I plug 4 in here, I get 2 plus 2, which is 4. So there's the minimum, and there's the maximum. 29. Can the mean value theorem, so we have f at x equals x divided by x minus 2 from 0 to 3. Does the mean value theorem apply? Well, there's a discontinuity at 2, which is in the middle of that interval, so no. So the mean value theorem does not apply. Why does it not apply? So at x equals 2 is a discontinuity. That's why. Number 30. What was that number 30? That was number 30. 29. I did number 30. Let me do not... Sorry, I did 30. 29. Find all the critical numbers. Now, this is a step function. This is what it looks like. So critical numbers is where the derivative is equal to 0 and where it's undefined, the derivative. So that would be, how do they name it? So it's all the numbers. So all the numbers would be then on there in terms of it, because the derivative is always 0. Or we have a discontinuity, which would also be on the number line. So all the numbers would be on the number, every real number. All right, 31. In question 31, find the C value that guarantees. Now for this one, it's continuous and differentiable. It's a polynomial, so it's easy to tell it passes that test. From -1 to 1. So this is I rock equaling A rock. That's what we're doing. That's the mean value theorem. So the derivative is 3x squared minus 2x minus 2. And then A rock is f at 1, subtract f at -1, and then 1 subtract -1. So if I plug in 1 take away 1 take away 2, that's -2. If I plug in -1, I get -1, I get another -1, and then that becomes plus 2. So that's all that 0, I think. Let me confirm I did it right in my head. I did. So altogether, -2 take away 0 divided by 2, that gives you -1. So that's what I'm solving. I'm going to add 1 to the other side. And then that's what I'm factoring. Because these are prime numbers, the only way to get to 3x squared is 3x times x. The only way to multiply to 1 is 1 times 1. Make sure the signs work so they add up to -2. So that's +1 and -3, so it matches. So we have -1/3 and 1. In my interval, do both work? Because 1 is right there. Well, I said you could use a calculator, but I didn't. So it has to be in the middle of the interval, so this one doesn't work. So the only one in the middle of the interval from -1 to 1 is -1/3. So 1 does not count. 32. A point moves along a curve, y equals the square root of x. So the y coordinate is increasing at a rate of 4. And it says find the rate for x when y equals 2. So we're going to write it calculus friendly, and then I'm going to take the derivative with respect to time. Remember the hook at the end there after you take the derivative. We know dy by dt is 4. I don't know what x equals, but if I plug 2 in for y, x must equal 4, because the square root of 4 is 2. And this is what I'm solving for. So the square root of 4 is 2, but then we do the reciprocal. To get the derivative by itself, multiply both sides by 4. So you get 16. And the units, right, is centimeters per second. All right, a few more left. 33. We're almost there. All right, take the derivative implicitly. This is the product rule. That's the first times the derivative of the second plus the second times the derivative of the first. Don't forget the hook, and that's 0. Factor out a y prime from -x and 2y. Subtract 2x and add y, and then divide. And you have your answer. (34) Find an equation of a tangent line. So right away, I'm writing this down. X is 1, y is -2. And we have that, the same equation that I did? No, different equation. X squared plus 2y plus y squared equals 1. So I need to take the derivative. There's no product rule here. Just remember the hook y prime when you take the derivative with y. So factor out a y prime. You have 2 plus 2y. Subtract 2x. So there's the derivative. I'm going to divide 2 out of everything. So that's what I'm left with. And then you plug in 1 for x and negative 2 for y. And that simplifies to 1. So it's y equals 1, x minus 1 minus 2. All right, last one, number 35. For a, it says take the derivative using the product rule. So we have the derivative of r times s at t equals 3. This is the product rule. The first times the derivative of the second plus the second times the derivative of the first. Plug 3 in for t after you do that. And then look at what each value is from the question. So r at 3 is negative 2. S prime at 3 is 5. S at 3 is 2. And r prime at 3 is 5. No. R prime at 3 is 3. So that's negative 10 plus 6, which is negative 4. The next one is the quotient rule. So do you know the quotient rule? So that is the bottom times the derivative of the top, subtract the top, times the derivative of the bottom, and then the bottom squared. Now plug in 3. So s at 3 is 2. R prime at 3 is 3. R at 3 is negative 2. S prime at 3 is 5. And then s at 3 is 2, and you square it. So that's 6 plus 10 divided by 4. So I get 4 for that answer. All right, last one. This is the chain rule. So in this form, the chain rule is the derivative of the outside times the derivative of the inside. When you plug in 3 for t, s at 3 is equal to 2. S prime at 3 is 5. One more time. R prime at 2 is 4. And then you multiply it together and you get 20. That's it. Mr. G Math over and out. I'm proud of you for doing your work and not giving up. Until next time.